Hello and welcome to another GCSE revision video, and in this video we're going to be looking at histograms. For the purpose of this video I've invented an imaginary country called Hypothetica, and here is a table showing the population of that country for ages 5 through to 18. Now, for the purpose of this video, we're going to treat age as continuous data because it is a measurement of time. Now, the first thing we want to do when drawing a histogram is to take our continuous data, because it is a continuum of numbers, we lump it together in what we call bins. Now, I've decided to lump the ages together according to the key stages in the British National Curriculum, but that decision is purely arbitrary. Now, for ages 5 to 7, I've got the frequency or the estimated numbers by adding the number of people aged 5, 6 and 7. And for ages 8 to 11, I've got that number 3,011,184 by adding the number of people aged 8, 9, 10 and 11. And so on throughout the chart. Now, before we go on with this video, I'd like to take a brief interlude to remind us all about upper and lower bounds. The upper bound of a value is the largest number that can round down to that value. And by the same reasoning, the lower bound of a value is the smallest number that can be rounded up to that value. And when dealing with measurements which are continuous data, we must consider the upper and lower bounds of those measurements. Now, from this we can get our interval width. So ages 5 to 7 actually don't mean just ages 5 to 7. They mean everything from age 4.5 up to, but not including, 7.5. So our interval width is 7.5 minus 4.5, which is 3. Again, for ages 8 to 11, we're not dealing with just ages 8 to 11. We're dealing with everything from 7.5 up to, but not including, 11.5. So when we subtract 11.5 from 7.5, we get an interval width of 4, and so on. Now, our ages range from 5 to 18, so we can take the length of space we have available to draw our x-axis and divide it by 18 minus 5, which is 13, and this should give us the space we need between the graduations on the x-axis. However, you'll note that the x-axis extends a little bit before the 5 and a little bit after the 18, remembering that 5 does not mean just 5, it means everything from 4.5 up to, but not including, 5.5. And of course 18 doesn't mean just 18, it means everything from 17.5 up to, but not including, 18.5. Now, we might remember on a bar chart we'd just make the height of the bar equal to the frequency, but on a histogram it's the area, not the height of the bar, that shows the frequency. So the y-axis shows the frequency density, which is the frequency divided by the interval width. So for ages 5 to 7, we've got an interval width of 3 because we subtracted 7.5 from 4.5. So we're dividing the frequency by 3 to get the frequency density. Again, for ages 8 to 11, the distance between 8 and 11 is 4 because 11.5 minus 7.5 is 4. So we're dividing the frequency by 4 to get the frequency density. Now, this of course means on your histogram your bars will be different widths. On a bar chart, they were all meant to be the same width. On a histogram, your bar charts will be different widths because it's the area, not the height, that we're concerned about. Now that we have our frequency densities, we can decide on a suitable scale for the y-axis. Now the data here is unnecessarily complicated, and on this scale of hundreds of thousands, I think it's best to round to two significant figures. Remember, what we're trying to do in statistics is remove the haystack so that we can find the needle. If we're going to get bogged down in unnecessary levels of accuracy, we might as well just give people the raw data to look at. But now that we have trimmed off the unnecessary levels of accuracy, it's a lot clearer to see what sort of scale we want to be looking at. Now I think it's going to be best to go from 690 up to 770 in steps of 10, and the y-axis should be labelled thousands. Of course, we could have gone from 69 to 77 and label the y-axis tens of thousands, but I think that adds a little bit more work for the reader to do, and we're trying to make our graph visually impacting so that the reader can see at a glance the information we're trying to convey. So here we have our y-axis labelled frequency density and labelled in thousands, and going from 690 up to 770. Now I want to make a little statement about this crumpling of the y-axis towards the bottom. If we're not going to start from 0, we always show that little wiggly line to show that there's a lot more of the y-axis that is not shown on the chart. And this can be a little bit controversial, especially on bar charts, because you're making a direct comparison of the heights of the charts. And if you crumple your y-axis on a bar chart, you're quite probably going to end up creating a chart that's misleading. You'll have to use your best judgment on bar charts whether you should crumple or not to crumple. But on histograms, that's not really such a problem because we're not making a direct comparison of the heights of the charts. It's the area of the bars, not the heights of the bars, that's important on a histogram. And when we combine the two axes, you'll note that we have crumpled both the x and the y-axis. Now the x-axis is not the dependent variable, so it really doesn't matter if we crumple that axis, whether it's a bar chart or a histogram. Now that being said, wherever you choose to start your axes, make sure you're consistent throughout that axis. Whatever interval space you've chosen, make sure you're consistent all the way through that axis. Don't decide, oh, I've run out of space, I'm going to just squash the numbers together. You can't do that. And don't change scale halfway through an axis, because that will result in a misleading chart. Now that we have our axes, we can start drawing in our bars, and you'll note that the bar doesn't start at 5 and end on 7, but starts at 4.5 and ends on 7.5. We must remember we're dealing with continuous data, so we begin drawing our bar at the lower bound of our interval, and we end on the upper bound of our interval, so that we have the correct interval width. And the other important thing when drawing a histogram is that your bars should run into each other. There should be no gap between your bars because you're dealing with continuous data. Okay, so once you've got all your bars, just check that you've got a descriptive title, a useful key, and that's pretty much all there is when it comes to drawing histograms. Lastly, I'd just like to summarise the differences between bar charts and histograms. Bar charts are best used to describe discrete data, while histograms are best used to describe continuous data. The bars are spaced out because the data is discrete on a bar chart, but on a histogram there is no space between the bars because the data is continuous. With a bar chart, the height of the bar represents the frequency, but with a histogram, the area of the bar represents the frequency. An awful lot of people do get bar charts and histograms confused, especially during the stress of an exam. Don't let that cost you valuable marks on an exam. Histograms and bar charts for the purpose of a GCSE exam are very different things and have very different rules. Okay, I'd like to wish you all the best with your revision and all the best with your exams. I hope you found this helpful. If you did find it helpful, don't forget to like, comment or subscribe, and I'll look forward to seeing you in a future video.